Alright, so today we are going to talk about factoring. So the first thing I want to talk about was factoring out the GCF. So I'm just going to take a look at a couple of these problems. I'm not going to do all of them. But if I look at this first one, what we're trying to figure out is what do the two pieces that we see here that are separated by the plus sign, what do they both have in common? Now, if I look at the first section here with the 16p to the fourth, we could write it differently. We could write it as 4 times 4 because that gives you 16. And then we could also write it times p to the third times p, because p to the third times p gives you p to the fourth. And in the second section, we can just leave it as 4p to the third. And what I'm trying to show you is what do they both have in common. And what they both have in common is they both have a 4 and they both have a p to the third. So what you can do is, in parentheses, you put those down, and what they have in common, you just write it once on the outside. So I'm going to write 4p to the third, that's the greatest common factor. And then the parts that are left over that they don't have in common is this 4p, so that has to go on the inside, plus, and this there's really a 1 there, so we got to put the 1 in there. And then this would be our answer. And this is how you factor using the greatest common factor. So take a look at a couple of different ones that maybe have some negatives and some other pieces in it. Number 2 is a little bit simpler. So some people can see right away that actually both parts, they both have a 9 in it. And what I mean by that is this first part you can write as 9 times x, and then the second part you could write as 9 times 4, because 9 times 4 gives you 36. So they both have the number 9 in common. So that's the greatest common factor. So I put parentheses, and I'm going to put that greatest common factor out front. And then what they don't have in common goes on the inside. So that's the x plus 4. So the greatest common factor is 9, and if you would multiply it back in, distribute it, you would still get this original. But we factored it. This is the factored form down here at the bottom of greatest common factor. Alright, so we just did 2 of them. We're good. This one maybe looks, number 5 looks a little bit different because it has negatives in it. But negatives really, it's not anything different. So I'm going to take a look and see what they both have in common. So if I look at the numbers, they both have a negative 6 in front. And then if you look at the letters, they really both have r to the fourth, because r to the fifth can be written as r to the fourth times r. So I'm just going to kind of break that down, even though some of you will get it just by what I said. So I could write this first part as r to the fourth times r is r to the fifth. And then the next part would be minus 6r to the fourth. So if you look at what do they have in common, they both have the negative 6, and they both have an r to the fourth. So put down my parentheses, and the greatest common factor is negative 6r to the fourth. And then what's left over is just going to be r. And I'm just going to put plus 1 because when I distribute it back in, I'll get the original. So you can do it when there's more than one part. A lot of people don't really know that you can, but if there's three parts, if they all have a greatest common factor in common, you can pull it out. So I'm going to look at this one, number 7. I'm looking just at the numbers first, and I realize that this could be written as 7 times 2, and this could be 7 times 3, and this can also be 7 times 3. And then I look at the letters. This one has an A. This one you could write as A times A, because that would be A squared. And this one you could write as A times A times A. And I'll put the plus signs in between here to separate them. So we're going to look at what they all three have in common. So they all have to share it. So they all three parts have a 7. They all have an A, one of them. But I think that's it. So the only thing I can pull out of here is a 7A. So I'm going to put my parentheses down. And the greatest common factor goes out front, which is 7A. And then the parts that are left, in the first part, there's a 2 that I didn't deal with. So I put 2 plus, and this one I need the 3A, plus 3 times A is 3A squared. So this would be what I'd do if I did it with 3 parts. Now this inside part often will end up having to do maybe box and circle on it, but it makes it simpler. So I'm going to try here with this number 9, and then I'm going to kind of call it good for greatest common factor, and then we'll move on to doing problems that need box and circle all the way. So if you look at number 9, looking for a number that goes into all 3 parts. Because there's a negative in front of each one, I can pull a negative out. They're all even numbers. -2 would come out. -4 would come out. I think -4 would be the biggest number, because I could write this as -4 times 7. This would be -4 times 2. And this would be -4 times 9. So I know they all have a -4. So I'm going to put my parentheses down. The greatest common factor goes out front. Here it's got to be -4. They don't share, all of them don't have the letter V in it, so I can't pull a V out. So what's left over is, this has a V squared, this has a V. So the parts that are left over is going to be 7V squared plus, because I took care of the negative with the -4, 2V plus 9. And that's pretty much how you do GCF.